Okay, so the last lesson that we did was on focusing on multiples. Okay, it was called multiples. It was when you're skip counting, right? Or creating equal groups of the same number. Today, we're going to focus on factors and factor pairs. So factors, please write what I write. Factors are whole numbers that multiply to get a product. Okay, I'm going to rewrite product for you. So as I erase, you guys can write. So factors are whole numbers that multiply to get a product. Okay. So if I said 4 times 2 equals 8, this is a factor, this is a factor, this is the product. Okay, please write what I write. These are important terms that you'll use for a long time, okay, for like into college. So factors are the numbers that you multiply by to get the product, okay? And then to even go farther, this 8 is a multiple of 2 and 4. So this is also known as a multiple, okay? Well, what did we learn about pair? Pair means 2, right? Well, how many factors are in this? 2. So when you have 2 factors that give you a product, you have a factor pair. Okay. I know that I write quickly. Please pause the video so you can get caught up. Okay. So factors are whole numbers that multiply to get the product. Factor, factor, product. The product is also known as a multiple because 8 is a multiple of 2, 2, 4, 6, 8, and it is a multiple of 4, 4, 8. Okay. Pair means 2 because there are 2 factors that give us this product. Those 2 numbers are factor pair, so they would be written like this. Okay. So now that we've gotten some of this terminology out of the way, let's go up to our question. Alfred is arranging 40 model cars into rows. He wants to put the same number of cars in each row. Find all the ways he can arrange the cars. So we know right away that we could do rows of 10 because it ends in a 0. So we go 1, 2, 3, 10. So if I do a row of 10 and I have 40 cars, how many rows would I need? Well, this is 10. So I would need 10, 20, 30, 40. So I would need 1, 2, 3, 4 rows. Let me fill these in. This is called an array. When you build an array, you have equal number of items in a row over and over again. They're also lined up like a grid. This is an array. And it's 4 by 10. The bottom, like there's rows of 10 and rows of 4. Okay. What are some other ways that you could arrange 40 model cars? You can choose to keep drawing them like this in different arrays, or we can do a factor tree. We'll put our multiple at the top, and then we're going to pull out our factor pairs. You could do 1 row of 40 cars. What number comes next? 2. 1, 2. You could do 2 rows, 2 times what equals 40? 2 times 20 equals 40. Could you do 3 rows? 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 37, 38, 39. Can't get to 40. So no 3s. Go by 4s. 4 times 10. Could you go by 5s? 5, 10, 15, 20, 25, 30, 35, 40. Ooh, times 8. Could you go by 6? Ooh, I think that I found a way to count by 6. 12, 18, 24, 30, and 36, 42. Oh, nope, it went past the 40, so you can't do 6. What about 7? 7, 14, 21, 28, 35, 42, 49. Oh, whoa, we went totally past 40. So no, you can't do 7s. And then we already have 8. We're starting to repeat ourselves, so we're going to stop. So these are the different rows that we could put them in. So this one right here, 4 times 10 is up here. So then if you wanted to do another one, it would be 1 row of 40, 2 rows of 20, 4 rows of 10, and 5 rows of 8. Okay, so these are all the different ways that you could arrange those cars. Okay. We're going to go to this connected side, and we're going to use this to help us. Okay. So we're going to list all the factor pairs of 40. Well, we just did it over here. So one factor pair is 1 and 40. Another factor pair was 2 and 20, 4 and 10, 5 and 8. So those are the factor pairs: 2 and 20, 4 and 10, and 5 and 8. 1, 2, 3, 4. 1, 2, 3, 4. Each number in a factor pair is a factor. How many factors does 40 have? Okay, so now we're not talking about pairs anymore. We're talking about only factors. So let's count our factors. 1, 2, 3, 4, 5, 6, 7, 8. 8 factors. Why might it be helpful to always start with the number 1 and work up when finding factors of a number? So we draw our tree like this and start with 1 and then work up 2, 3, 4, 5 so that we know we're not going to miss a number. Okay, so if we go in order like this, 1, 2, 3, 4, 5, and then find the factor that goes with it, we know that we're not going to use the 3, but we didn't leave it out. We still tried the 3. So why might it be helpful to always start with number 1 and work your way up when finding the factors of the number? Well, it's helpful because you know that you're not going to miss anything. You're not going to accidentally miss a factor. Explain. Okay, so it says it's helpful because you know you're not going to accidentally miss a factor. And pause the video if you need to write it. So number 4, explain how to use arrays or area models to find factor pairs. Well, you could do it the same way as the factor tree. And if you want to find a factor pair of 10, you could do the tree. But if we're going to use arrays, you would just start drawing 10. You'd do 1 row of 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ooh, that works. Factor pair, 1 by 10. And then if you want to do the next one, you'd go by 2s. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You see how they're equal? So that factor pair is 2 by 10. Nope, no, Mrs. Cast, not 2 by 10, 2 by 5. And then go to 3. 1, 2, 3. 3, 4, 5, 6, 7, 8, 9, 10. Oh, well, look, it's not equal. This is row 3, 3, 3. This is only a row of 1. It has a remainder, so there are no factor pairs 4, 3. And then so on. So we started with 1, 2, 3, just like we would do on our factor tree. 1 times 10, 2 times 5, 3 times, oh, doesn't work. So we try it over here for number 4. So if we wanted to try 4, we'd go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Can 4 be a factor pair of 10? No, it can't, because it doesn't have the equal numbers. This has rows of 3. This only has rows of 2. Cannot be. Okay. So look back at your try it strategies. Which model or strategies do you like best? Okay, so do you like the factor tree? Or do you like drawing the array? And then just tell why. All right, let's practice. Number 6. Brad has 18 blocks. He wants to make an array with the same number of blocks in each row. What are all the different ways Brad can arrange the blocks? Show your work. So what are the different ways Brad can arrange the blocks is the question. The important information is that he has 18 blocks and he wants to use an array. Okay, so let's start with 1. Okay, he has 18, so we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So this one is 1 by 18. Okay, number 2. So how many rows am I going to use for number 2? 2. So 18 blocks, so we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 18. That's it. So we can count 1, 2, 3, 4, 5, 6, 7, 8, 9. So we know our factor pair here is 2 by 9. Well, let's do number 3. How many rows am I going to have for number 3? 3 rows. And they need a total 18. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Whoa, 3 is also a factor of 18. The factor pair would be 3 by 1, 2, 3, 4, 5, 6. By 6. Is 4 a factor pair? Or can 4 be used as a factor to make a factor pair? How many rows am I going to make for 4? 4. What am I going to count to? 18. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Can 4 be used as a factor of 18? No, it cannot, because there's this stuff. It has to be equal all the way across. So 4 is not a factor. Can 5 be a factor? Well, I'm going to tell you right now, 5 cannot be a factor because all factors of 5 end in 0 and 5. So listen, 5, 10 ends in 0. 15 ends in 5. 20 ends in 0. 25 ends in 5. So 18 cannot be a factor of 5, or a multiple of 5. Can we do 6 rows of 3? Sure can. But it is the same factor pair, but then they just get switched the other way. So then it's the same factor pair, but it'd be 6, 3. So it'd go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. This would be 6 by 3. Same factor pair, they're just facing the other direction. So you could do the same for this one too. You could go 9, 12, and you could go 18, 1. So what are the factors of the number 27? So for this one, let's do a factor tree. So we're going to put our multiple at the top, which is 27, and we're going to pull out our factors. And we're going to start with 1 times 27. 2, oh, that's not an even number, so we can't use 2. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. We cannot get to 27. Let's try 3. 3, 6, 9, 12, 15, 18, 21, 24, 27. That's 9. So times 9. About 4. 4, 8, 12, 16, 20, 24, 28. 30. Nope, can't do 4. 5. Does it end in 0 or 5? 6. Ooh, I think that I found a way to count by 6. 12, 18, 12, 18, 24, 30, and 36. Oh, went right past 27. Nope. 7. 7, 14, 21, 28, 35, 40. Oh, wait. Way past 27. Nope, not 7. 8. 8. 8 times 2 is 16. 8 times 3 is 24. 8 times 4 is 32. So we cannot use 8. We're back to 9. We've already done 9, so we don't need to repeat ourselves. So the factors of 27 are 1, 3, 9, and 27. Heidi arranges 12 photos on pages in her photo album. She puts the same number of photos on each page. Which list shows all the possible numbers of photos that Heidi can put on the page? Okay. She puts the same number of photos on each page. So we'd have to find all of our multiples of 12. And we're going to list all of the possible numbers. Not some, all of them. So 1 times 12, 2 times 6, 3 times 4. 4, we're already starting to repeat ourselves, so that means we're done. So it will need to have all of these numbers in there. Okay, so we can't use this one because there's not 1. Okay, 1, 2, 3, 4, 6, 12. Ooh, this one's looking good, maybe. 1, 2, there's no 2, can't use this one. 1, 2, 3, 4, 6, no, not 8. Can't use this one. The answer is C. Please write what I write. Okay, guys, I know it seems like a lot, but doesn't it look so pretty once we're done? Math is so pretty. So now please move on and do page numbers 157 and 158. There is a Google form for you to put all your answers on. A good day.